In this lesson, we will give an introduction to cluster analysis. We will go over the definition of clusters and cluster analysis, discuss applications, requirements, and challenges, and give a high-level overview of clustering methodologies, different types of data, and user insights. Let's start with defining clusters. What is a cluster? A cluster is a collection of data objects that are similar to one another within the same group or a cluster, which means objects in the same cluster are related or close to one another, whereas objects that belong to different clusters are different or dissimilar from objects in other clusters. Now, what is a cluster analysis? It's the process of performing a clustering. So, given a set of data points, a cluster analysis is the process of partitioning these points into a set of groups or clusters. And objects within each cluster are similar as possible, whereas they're different if they belong to different clusters. A cluster analysis belongs to unsupervised learning, which means there is no predefined classes or labels. This is in contrast to classification, which is supervised learning, where the class labels are already known and we train a model to predict them. There are several ways to use a cluster analysis. It can be used as a standalone tool to gain insight into a data distribution. And it also can be used as a pre-processing or an intermediate step for other algorithms, such as classification, predicting, and other data mining tasks. Examples are online in use, grouping articles into categories, recommendation systems, as grouping users, movies, etc. Now, what makes a good clustering? A similarity measure that used for cluster analysis should address two important metrics, which are the high intra-class similarity and low inter-class similarity, which means the members of one cluster should be as cohesive as possible, and members of different clusters should be as distinctive as possible. On the application side, one use of clustering is as a pre-processing or intermediate step for other data mining activities. For example, generating a compact summary for classification, pattern discovery, hypothesis testing, and so on. And it can also be used for outlier detection, because outliers are those points that are far away from any cluster. Another important application is data summarization, compression, and reduction. Examples in image processing. There's a technique called vector quantization, which makes use of clustering to compress an image efficiently. Cluster analysis is also widely used in collaborative filtering, recommendation systems, customer segmentation. Here, clustering helps finding like-minded user or identify similar products, which is very useful in marketing. More applications as in dynamic trend detection. For example, by clustering a stream of data, we can detect evolving trends and patterns over time. Finally, cluster analysis has been very helpful in multimedia data analysis, biological data analysis, and social network analysis. Considerations for a cluster analysis. The first one is the partitioning criteria. That means we need to decide whether we want a single level, hierarchical partitioning, or even multi-resolution, multi-hierarchical partitioning. In many applications, hierarchical clustering can be desirable because it gives a detailed and a structured view of how the clusters are formed at different levels. The second consideration is the separation of clusters, which can be exclusive or non exclusive. Exclusive clustering, each object belongs to only one cluster. For example, a customer can belong to only one region. On the other hand, in non exclusive clustering or soft clustering, one object may belong to more than one cluster. For example, a document might be related to multiple topics or categories. Now, here's a question for you. In a movie recommendation system like Netflix, what are the consequences of implementing exclusive and non exclusive clustering criteria? The third consideration is the similarity measure. There are many ways to define similarity. We can use distance based measures like Euclidean distance, road networks, or vector similarity. Or alternatively, we can use connectivity based measures, which depend on density or contiguity. For example, how closely the data points are grouped together in the space. Another consideration is clustering space, which refers to whether we perform clustering in full space or subspaces. Full space clustering is often used when the data has low dimensions. However, in high dimensional data, it's very hard to find meaningful clustering. So, subspace clustering can be very useful because it helps finding interesting and meaningful clusters within the lower dimensional subspaces. For clustering challenges, the most important one is quality. We need to consider whether our method can handle different types of attributes such as numerical, categorical, text, multimedia, network, or even a mixture of these types. We also want the algorithm to be able to discover clusters of arbitrary shapes, like an oil spill in the ocean, not just round or spherical groups. Another desirable quality is the ability to handle noise in the data, since data is rarely perfect. And another major concern is scalability. Can the algorithm handle large data sets, or does it only work on a small sample? We also need to think about high dimensional data, whether the algorithm can manage many features directly or it needs to project the data into a lower dimensional space, which requires pre-processing. Additionally, in today's world of continuous data, we need methods for incremental or stream clustering. So the systems can update a cluster as a new data points arrive. Constraint-based clustering, users often have their own preferences or constraints, and they will bring this domain knowledge to identify certain subspaces or relationships that are important and interesting to their queries. Finally, the interpretability and usability of clustering matters because a good clustering method should produce meaningful clusters that people can understand and use. In summary, we gave a brief introduction to cluster analysis.